Welcome, scientists, to today's edition of physics. In this short video, we are going to look at solving problem 66 from chapter 4. With that, let's get started. In problem 66, we have a particle that moves along a circular path confined to the XY coordinate system. This particle has a constant speed, but since it's moving in a circle, it clearly has an acceleration, in this case, a centripetal acceleration. They give me information about the particle at time t equals 1 and at time t equals 2, and they ask me to find a bunch of information. So let's draw out our picture and write our given information. We know that at clock reading 4 seconds, the particle is at a point 5 meters over, 6 meters up, moving with a velocity that is 3 meters per second, j hat. And we know that the acceleration is in the positive x direction. And at clock reading t equals 10 seconds, we know that the velocity is directed in the negative x direction, and the acceleration is in the positive x direction. So knowing that my object is moving around in a circle, I can conclude that the particle is moving along that kind of circle. So the particle has to be down there somewhere at clock reading 10 seconds with a velocity and an acceleration. In addition, this problem tells us that the particle has not yet made a complete circle because it tells me that t2 minus t1 is less than 1 period. So I can figure out what is that time interval. So my time interval between points 1 and 2 is 6 seconds, but that hasn't made a full period yet. The particle has only made 3/4 of a period. So I can deduce that the period of the particle is 8 seconds. I'm able to put all that together because I know that the velocity of this particle is going to be the distance traveled divided by the time. Well, I know that the distance traveled is equal to the circumference, 2 pi r, in the period, t. Since this problem asked me to solve for the radius, I'm going to go ahead and do my algebra and rearrange this for r equals. Plug in what I know. And I find out that the radius of my circle is equal to 3.82 meters. Therefore, this problem asks me to find the center of my circle. Since I know my particle began at T1 at a position of 5 meters over and 6 meters up, I see that the center of my circle has to be at 8.82 meters in the x direction and 6 meters in the y direction. So there you have it. We were able to see how we could use the given information and our knowledge of circular motion in order to solve for the center of that circle. That's all for this episode. We'll see you in the next one.